All right, guys. Sorry I can't be there today to help you through these notes. I'm at an appointment, so I'm fine. I'm not sick or anything. In fact, some of you probably saw me in the hallway this morning. So, um, just going to get you these notes and then get you some practice, and then I will look forward to seeing you all on Wednesday. So on Friday, when you were home, you were supposed to watch that percent operations video from the guy on Math Antics, who I kind of love. He's amazing, and his videos I think are very relatable. So hopefully it wasn't too terrible, and you were able to go into Canvas and answer a few questions on how to find the percent of a number. So we're going to just take a few notes here on how to, like, why you would use it in real world situations. And then, like I said, you will have some practice. So first of all, there were a couple ways that he described how to find percent of a number. One of them was setting up a proportion. One of them was just multiplying the decimal equivalent. And that's what I'm going to focus on here today. So if you prefer to do the proportion where you have the percent value over 100 equals something over, that's fine. By all means, use that. But I just think this might be more to the point and more efficient to do it this way. But again, you guys know this. As long as you get the right answer and I can see your work, I'm happy however you decide to work out a problem. So let's just refresh our memories and go ahead and take a couple notes on how to find the percent of a number. Okay. So we've got some examples. So example number one, if I want to find 23% of 82, right? Two kind of random numbers. So if you remember from the video, he advised you to take this percent and turn it into a decimal. And remember, of means to multiply. So we're going to do 0.23 times 82. So out to the side, 0.23 times 82. Got my 0 placeholder. 8 times 3 is 24. Carry the 2. 8 times 2 is 16 plus 2. 18. So I've got 6, 9, 8, 1. And then I have two numbers behind the decimal here. So I need two decimals behind the two numbers behind the decimal here. So my answer is going to be 18.96. Right? So I simply turned this percent into a decimal, which I know you guys can do. You can all convert percents to decimals and then multiply times the number I'm taking that percent out of. Okay, so let's do one more for good measure. We're going to find 4% of 91. Okay, so this is where it gets a little tricky because how does 4% get written as a decimal, right? So what I've got here is 0.04 times 91, okay, because 4% as a decimal is that 0.04. So I've got 40, placeholder, 6, carry the 3. I've got 2 digits behind the decimal here, so I need 2 digits behind the decimal here. So my answer is going to be 3.64. Okay, so that's kind of the strategy we're going to use to find percent of a number. So now let's get into some real world examples. So let's talk discounts, right? Who doesn't love a discount at a store? Okay, you know, like right now 40% off or 25% off or buy one get one 50% off, things like that. Everybody loves discounts. Okay, I have a theory that Kohl's actually marks prices up so their discounts seem pretty cool, but that's just my theory. I have no proof, but I believe in that. Anyway, side note. Okay, so let's say we have, and I know you all love shoes that cost $120. And I don't know, I mean, maybe that's expensive to you, maybe not. That's pretty big that would be a pretty big part of my shoe budget, okay? And they're on sale for 20% off. Okay, so I need to find a new value, right? What's the new value? New price. All right, so I'm going to do $120 times, and then what is my decimal equivalent of 20%, right? So I'm just going to say 0.2. It is 0.20, but it's either way. If you put the 0.20 or just the 0.2, you're going to get the same answer. So I'm going to work this out. 0 times 2 is 0. 2 times 2 is 4. 2 times 1 is 2. I've got one digit behind the decimal, so I just need one digit behind the decimal here. So that's my discount, but what's the new price, right? So this is the discount, but that's not how much I'm going to pay for the shoes. So in order to find out how much I'm going to actually pay for the shoes, then I have to go back to the original price and take away the discount, right? So 10 minus 4 is 6, 11 minus 2 is 9. So the new price is $96. Okay, so one of the biggest mistakes that 8th graders make is they stop here and they say, oh, well, the shoes are $24. Not quite. That's just how much you don't have to pay now. So you have to subtract that from the original price. All right, so let's move on to page 12 and we'll do a couple more examples of discounts. I know you all also love video games. I don't know how you buy them or rent them or what have you. So let's say you have a video game that costs $40. And again, I have no idea if that's a normal price or not. My kids aren't into that yet. And it's on sale for 15% off. What's the new price? Okay, so again, I'm going to take this $40 times 0.15 because it's a 15% discount. 0 times 5 is 0, 5 times 4 is 20, 0 placeholder, 1 times 0 is 0, 1 times 4 is 4. I have 2 digits behind the decimal here, so I need 2 digits behind the decimal here. So that's my discount. So then I'm going to go back up here and take the original, subtract my discount, and I get 34. So the sale price is $34. Right. Okay, how about cell phones? We all love cell phones. I don't know if you've ever talked to your parents about the actual cost of a cell phone, but they're not cheap. I mean, it's a computer. You're basically carrying a computer around. So I did some research, and cell phones can cost somewhere around $750. That's probably why your parents get so upset that you break it, crack it, lose it, whatever, because they're just not cheap, okay? And you're getting one on sale for 35% off, right? Maybe they're getting ready to roll out a new version, right? iPhone 12 or something. So the 11s go on sale. I know there's not an iPhone 12. I know that right now the current one is an 11. I'm not that old, but you know what I mean. Like they start discounting the older models, okay? So what is going to be the new price? All right, so I've got $750. 35% is going to be 0.35. 0, 5, carry the 2, 35, 37. 0 placeholder, 3 times 0 is 0. 3 times 5 is 15, carry the 1. 3 times 7 is 21, plus 1 is 22. Carry the 1. 2 digits behind the decimal up here, so 2 digits behind the decimal there. So that's my discount. That's not the new price. So now I have to take that $750 and subtract $262.50, right? And this is why we spend all that time on those decimal operations and things, because there's a lot of zeros in this number. So we have to make sure that we borrow accordingly. 0 minus 0 is 0. I can't do 0 minus 5. I can't do 0 minus 2. So this is going to turn into 4. This turns into 10. And then this turns into 9, and this turns into 10. 10 minus 5 is 5. 9 minus 2 is 7. I can't do 4 minus 6, so I have to borrow. 14 minus 6 is 8. 5 minus 2 is, this should be a 6. 6 minus 2 is $487. So the new price is still pretty expensive, $487.50. So next time you tell your parents you want a new phone, you better get to doing some chores, mow the yard, take the trash out, what have you. Okay, so that's discounts.